Welcome to Cognition and Problem Solving. In today's lecture, we will cover what is cognition, problem solving and decision making, trial and error, algorithms, heuristics, means and analysis, insight, barriers to problem solving, confirmation bias, functional fixedness, mental sets, and creativity, and discussing convergent versus divergent thinking. So, what is cognition? Cognition is the mental activity that happens in the brain when a person is processing information. This processing allows an individual to organize information, attempts to make sense of and understand information, or communicate that information to others. Cognition can include memory, but it is more than simply recalling information. With cognition, a person is aware of the information in their brain and is using that information to make a decision or solve a problem. Cognition is also known as thinking. So, what are mental images? In addition to thinking in words, people also think using mental images. These images are mental representations that stand for objects and events and have a picture-like quality. Now we'll talk about an experiment called the window experiment. In an interesting demonstration of mental images, psychologists asked research participants to indicate as quickly as they could how many windows are in their house or apartment. They noticed that participants looked up as though viewing a picture only they could see. They also found that people with larger residences and more windows took longer to answer. Psychologists believe that in answering this question, people picture their house or apartment and mentally walk through this image, counting windows in each room. Here's some fun with mental model imagery. Which side of the sink is the cold water knob on? What color are your best friend's eyes? And is the doorknob to your house on the right or the left? If you are like most people, in answering these questions, you considered a mental image. You likely recalled an image of your kitchen or bathroom sink into your mind to picture which side the cold water knob is on. Using mental images, people are also able to complete mental rotation tasks in which they turn over or move images around in their mind. For instance, when people are shown a picture, they can use mental rotation to imagine that picture from other sides or angles. For a mental rotation exercise, you can use this link that will be below or follow along. For each number in the matrix that will be shown on the next screen, decide whether it is normal or reversed, as in this example. Are you ready? Now, when looking at these numbers, being turned is not the same as being flipped. So think of this as either normal or reversed. What do we think about which numbers are normal and which are reversed in this graphic? So row 1 was normal, reversed, reversed. Row 2 was normal, normal, reversed. And row 3 was normal, reversed, reversed. Here's another one for you. In which direction is the bus pictured traveling? Do you know the answer? The only possible answers that we're looking for are left or right. When preschool children in the US are shown this brain teaser, they often answer left. Why is that? It's because they say you can't see the door. Because they have daily exposure, or at least most days exposure to school buses, they know that if they can't see the door, the bus is obviously going to the left for them, right? Or that way down the street. Here's a brain exercise to help stimulate your mental rotation skills. The top shape will be the model. Among the 3 shapes below the model, only one matches. To figure out which one does, you will probably have to move the shapes around in your head. Move the shapes from left to right or right to left, but do not flip them around. Here's the first set. Which of the bottom three matches the top one? If you guessed the middle one, you're correct. How about this one? Which of the bottom three shapes matches the first one? Again, it was the middle one. Then here's the last one. Which of the bottom three shapes matches the top one? If you guessed this one, you're correct. So let's talk about understanding mental concepts. Mental concepts help organize information. The definition is that concepts are ideas representing classes or categories of objects, events, or activities. The purpose of them is to aid in the identification and categorization of new objects or events. So, the concept furniture includes defining characteristics such as permanence and functionality in a house or office. This ability gives us a way to classify new furniture objects based on these defining characteristics. You have some idea of the important defining characteristics of furniture. Your concept might indicate that furniture is any relatively permanent object that serves a function in a house or office. Even if you see some odd, modern-looking piece of furniture you've never encountered before, you can still classify it using the defined characteristics of your concepts. So long as this new piece looks relatively permanent and clearly serves a purpose in a house or office, you are very likely to label it as furniture. Here's another example. Dog. The concept of dog involves key features like being a four-legged furry animal that may bark and wag its tail. The ability to classify this would be helping us to understand what new animals are based on the defining characteristics of our concept for dog. So you have some idea of the important defining characteristics of dogs. Your concept might say the four-legged furry animal, it might bark, it might wag its tail like we mentioned before. And then when you meet a new animal, your mind compares it to all of your existing concepts. Dogs, cats, bears, guinea pigs, all of those, and see which concept it most closely matches. If the animal has four legs and barks, you will likely label it as a dog. Concepts are important, not just because they allow us to label and categorize new objects, but also because they help us communicate with others. If, for example, you ask a friend to help you move some furniture, your friend will understand what you are asking because you both have mental concepts for furniture. Similarly, if your daughter approaches you about wanting to adopt a cat, you will understand her request based on your shared concept of cat. You may have noticed that some cats seem more cat-like than others, and that some pieces of furniture have more clear function or purpose than others. For instance, it may have occurred to you that some cats are hairless. We would likely be able to label this creature as a cat, but it might take us longer to do so because it meets some, but not all, of our defining characteristics. This leads us to the idea of prototypes. A prototype is an example of a concept that closely matches the defining characteristics of that concept. When people are asked to think of furniture, they tend to imagine a chair more quickly than a footstool. A chair closely matches the defining characteristics of furniture, a relatively permanent piece that serves some function. So when we hear the word dog, most people think of some sort of golden retriever looking animal. For many people, this is the prototypical dog. Golden retrievers match most people's defining characteristics for dog. They are not too small, they're not too large, they have four legs, they have fur, they might bark. You might object at this point and say that when you think of dog, you picture your family's dog, Buddy, who is not a golden retriever. But that's because prototypes do depend a little bit on personal experience. Growing up with Buddy may have helped to shape what you consider to be the defining characteristics of what makes a creature a dog. Prototypes are important because they help us to classify and categorize new objects. As we noted earlier, when people encounter a new object, they compare that object to the defining characteristics of their mental concepts. To speed up this process, we often compare newly encountered objects to our prototype. When you meet a new animal, you compare it to your prototypical dog, Buddy, to see if this new creature possesses the characteristics to make it a dog. Prototypes and concepts allow us to quickly and easily make sense of all the sensory information we are bombarded with each day. As we've learned in previous weeks, conscious attention is limited. Concepts and prototypes allow us to categorize objects swiftly so that our attention can focus on other things. Concepts are also important tools in problem solving. Here's a video that talks about what people think a typical item is. It will be linked below. Problem solving and decision making. Mental images, prototypes, and concepts are important tools in decision making and problem solving. Problem solving is the cognitive processes that occur when a goal must be reached by behaving and thinking in certain ways. There are many ways that humans approach problem solving. Some approaches that we'll discuss here today include trial and error, algorithms, heuristics, means and analysis, and insight. Trial and error. Let's talk about this method. This is a method where a person tries one possible solution after another until something works. For example, Sheila's computer stops working, so she tries a number of different things. First, she hits Ctrl-Alt-Delete and tries closing programs. Then, she tries using the power button to restart her computer. Then, she unplugs the computer and plugs it back in. Then, she might run her virus and malware scanners. And then she could uninstall various programs. Sheila keeps trying option after option until she finally finds a solution that fixes her computer. Let's talk about algorithms. Algorithms are step-by-step procedures for solving certain kinds of problems. You may have learned PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction to complete math problems using order of operations. The good news about algorithms is that if you follow them properly, you will always find the correct answer or solution. The potentially bad news about algorithms is that they can be very time-consuming. Imagine you have a locker at work that you don't use very often. One day you decide to put your gym bag and lunch in your locker. When you return at midday, you cannot remember your combination. An algorithm exists to solve this problem. You could try every single possible combination of 3 digits until you find one that works. It would take a very long time. For this reason, people often use mental shortcuts or heuristics. Heuristics. Let's talk about this. This is a rule of thumb or an educated guess based on past experiences. Heuristics provide quick estimates about the likelihood of uncertain events. Where algorithms will always lead us to the correct solution, heuristics can sometimes cause us to ignore important information and make an incorrect decision. Two commonly used heuristics are the representativeness heuristic and the availability heuristic. The representative heuristic involves judging the frequency or likelihood of an event by the extent to which it resembles the typical case. The saying, if it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck, is an example of the representativeness heuristic. Here, you're classifying an animal as a duck because of the extent to which it resembles the typical duck. But heuristics can sometimes lead us astray. Many people have had the experience of needing help from a store employee only to find the person they approached was actually just a fellow customer. This type of error can occur because of our use of the representativeness heuristic. The person we approached may have been dressed in khakis and a polo shirt, just like store employees. This means they resemble the typical case of store employee. Our reliance upon the representativeness heuristic leads us to ignore other sorts of information, though. For example, had we stopped to carefully think things through rather than using a heuristic, we might have noticed the person's shopping bags on the floor next to them. The availability heuristic involves judging the frequency or likelihood of an event by the ease with which relevant instances come to mind. One problem with using the availability heuristic is that this ease is influenced not only by the actual frequency of an event, but also by the salience, noticeability, and recency of the event. So imagine that you need a new cell phone, and as you stand in the store, you are debating whether to get an iPhone or an Android. To make this decision, you could stop and think carefully and logically, perhaps using an algorithm. You could carefully comb through research and read customer reports, consumer reports. But because people have so many decisions to make on a daily basis, they don't often engage in such careful thought and they'll use heuristics instead. So, standing in the store, you might use the availability heuristic and think about how often your friend has complained about their iPhone dropping calls, the emojis it doesn't have yet, how easily their phone broke when it fell from their bag, all sorts of examples. Because you can call so many instances of iPhone problems to mind, you decide the iPhone must not be a very good product, and you buy an Android phone instead. The problem here is that your friend might be particularly loud and vocal about iPhone issues. It's possible that there are many things she loves about her phone that she fails to share. It's also possible that Android phones have just as many problems. You just are unable to call them to mind because you don't have any friends with Android phones talking about them all the time. Your use of the availability heuristic may have led you to an incorrect conclusion. Let's talk about means-end analysis. This is the difference between your starting situation and your eventual goal. When this is determined, this difference between the two is determined, and steps are taken to reduce that difference, that's means-end analysis. This involves breaking a larger task into smaller, more manageable steps. You have used means-end analysis when completing projects for your classes. Your eventual goal is to have a finished product that you can upload to your course. You take smaller steps throughout the course of the session to reach this goal. For instance, early in the session, you would complete a topic selection post. Then, as you build an outline, you work to find the references and sources you'll use, you complete the outline, and then you get feedback from instructors and peers on a rough draft. Let's talk about insight. At some times, you might feel like you've been working on a problem for quite a long time and are getting no closer to an answer, when all of a sudden an idea or correct solution just pops into your head. This occurrence is known as insight. Though it feels like the correct answer comes out of nowhere, with insight, the mind has been working, perhaps without your awareness, on reorganizing the problem and thinking about things in a new way. This is why it can sometimes be beneficial to step away from a problem and try to focus on something else. While you're working on the new task, your mind can be reorganizing and processing information in the background. Let's think about these questions and see how easy it is for us to come up with the answers. In this example, they're asking us to move a single line so that the false arithmetic statement becomes true. The answer would be to convert the 4 to a 6 by moving the stick to the end or the line to the end. How about this one? Move a single line so the false arithmetic statement becomes true. It's a tautology, so rearrange the plus sign to make an equal sign. Here, we're going to add a single line so that the false arithmetic statement becomes true. Did you figure it out? It was adding a diagonal line to the plus sign to make it into a 4. Then it becomes 145 plus 5 equals 150. Here's another question to consider. A prisoner was attempting to escape from a tower. He found a rope in his cell that was half as long enough to permit him to reach the ground safely. So he divided the rope in half, tied the two parts together, and escaped. How could he have done this? He divided the rope in half widthways rather than lengthways. He unwove it and then tied the two ends together, making a long enough piece to make his escape. How about barriers to problem solving? Let's think about this. Functional fixedness, mental sets, and confirmation bias are all things that can challenge us when we are trying to solve problems. Confirmation bias is how people have a tendency to notice and search for information that confirms their beliefs and to ignore information that disconfirms or disagrees with their beliefs. Without even meaning to, people may not be using all available information when solving a problem. They may instead only be using information that fits within their existing ideas or beliefs. Functional fixedness occurs when a person thinks about objects only in terms of their typical functions or uses. A classic example of functional fixedness comes from Dunker's candle problem. To see a demonstration of this problem and learn more about how having abundant resources might interfere with creativity, please watch this following video. This slide shows a video that will be linked below. The candle problem is a situation where different age groups react differently to solving a problem. There's a box of tacks, a candle, and a book of matches. And the people are asked to attach the candle to the wall. Older people or adults usually tend to try things like melting some of the candle or putting a tack through the candle or something like that. But younger kids are very quick, below the age of 6 really. Kids 6 or younger are very quick to dump the tacks out of the box, look at the box as a separate tool, and then solve the problem by tacking the box to the wall and putting the candle in the box. In this video, the person talking discusses how, as we get older, having more resources forces us or takes away our ability to force ourselves to think a little bit more creatively, because when we didn't have those resources, we had to solve a problem with what we had. But sometimes as we get older, we get more resources. And that can cause us to lose a little bit of creativity because we have access to solve our problem by getting help or buying some tool or doing something like that, versus not having the ability to add anything to the equation and having to think very creatively to solve the problem ourselves in the first place. Let's talk about mental sets. When a person uses a mental set, they persist in using problem-solving patterns that have worked in the past. You may have seen an example of a mental set if you have ever played hide and seek with a child. If the first time the child successfully found you, you were hiding behind a chair, the child is likely to return to that same chair to look for you even after you have changed hiding spots. The child is continuing to use a problem-solving method that was successful for them in the past, which was looking behind the chair. You may also have experienced a mental set if you completed the thinking out of the box examples that we talked about earlier in this lecture. If you notice that you successfully completed the first problem by moving one of the sticks in the numbers, you might have tried to keep using this strategy in later problems. This would have led to frustration, though, because some of the later problems involved altering the operation signs instead. Thinking about creativity, Logical problem solving is also referred to as convergent thinking because all lines of reasoning should converge on or lead to the one right answer to the problem. Creativity requires combining ideas, information, and behaviors in new and different ways to solve a problem. Creativity is a form of divergent thinking, where a person begins at a starting point and comes up with as many different divergent ideas as they can. A classic divergent thinking or creativity exercise involves asking participants questions like, how many different uses can you think of for a paperclip? Here, participants list not only the convergent answer, which would be fastening papers together, but also more creative answers like designing jewelry, cleaning out one's computer board, or doing something else with the paperclip that's not holding papers. Creativity helps people to avoid many of the barriers to problem solving noted earlier. So, what enables someone to become a creative thinker? Are there characteristics that creative thinkers have in common? And is it possible to improve your creativity? Creative people tend to be knowledgeable about a wide variety of topics and are usually skilled at using mental images. They are also not afraid to be different from others. In terms of personality dimensions, creative people often score high in openness. Creative individuals often value their independence and are often unconventional in their work. And this doesn't necessarily mean they have unconventional jobs. They could have very conventional jobs, but they might approach their tasks in an unconventional way. Research has found that the most productive periods of creative thinking occur when a person is engaged in a task that is more or less automatic, like walking, showering, or washing dishes. During these activities, part of the mind is focused on the task at hand, while another part of the mind is dedicated to creative thought. Psychologists believe that these periods are so productive because, with the mind divided, the person does not censor or criticize their ideas and instead allows them to flow freely. To stimulate your own creativity and divergent thinking, you might find the following tips helpful. Engage in brainstorming and free writing. Try to generate as many ideas as possible, writing each idea down without judgment. Write down your thoughts without revision or editing. You could keep a journal. Carry a journal in which you can jot ideas and thoughts as they come to you. So this doesn't mean a diary, really. It just means some sort of notebook or maybe an app in your phone where if you think of something interesting throughout the day, you can just put it in there and then forget about it and check it out later. You could also use mind or subject mapping, starting with an idea and drawing lines between that idea and other ideas that strike you as interesting. This will help you to see how various ideas and topics are connected. This concludes the section on cognition and problem solving.